Hello everyone, in this video we will talk about what is generator function, what is the difference between generator function and the normal functions, and what are the advantages of using generators in Python. So let's get started. So when we talk about normal function, let's say I have a list which contains 10, 20, 30, 40, 50 and 60, and I'm writing a very basic function called printval, for which I'm passing this list L, and this function will print all these values. So how to define a function? So I'm writing def, then printval, pass this list. I need to iterate, so I'll write for loop. So for value in L and print value. So for a normal functions, when we write a function call, it will transfer the control to this function. It will execute this entire function and it will come back to the caller. This is a normal flow. It is not saving the state. Now let's take a situation where you are generating a huge series of numbers. Let's say you are generating infinite prime numbers or infinite Fibonacci series number. So whenever I will give a function call, it will take time and it will infinitely keep on executing and calculating the numbers. So on the other hand, generator functions are special type of functions which will maintain the state of a function, and it will return one value at a time, or it can return the number of values which you want. Okay, so let's see how to define a generator function. So I'm taking an example of a Fibonacci series. So let's write a function called Fibo. This is a function call I'm writing. Let's write a function definition. So expectation is this function should return me infinite Fibonacci series numbers. Okay, so I'm writing Fibo. Alright, let's take one variable as first num. Initially this is 0, then second num is equals to 1. I'm writing a while loop and I want it infinite, so I'm writing while true. I will calculate the next value. So next val is equals to addition of first num and the second num, so first num plus second num. Okay, and this is the output, so I can store it in a list, and once I get this output I need to swap the two numbers, and after this I need to write now the first num and the second num will be second num comma next val. Okay, now instead of writing the return statement or adding to a list, here I'm adding one more statement, and that is yield. I'm saying yield next val. Okay, so let's see the output. So if I say g is equals to this, and now let's print this g and let's see the results. So this will return me a generator object. Okay, so if I write a yield statement in a function, then that particular function is called as a generator function. So now when I print a g, it is printing me a generator class object. It is an iterable object. Now how to get output from this? So if I write this method called next, it will generate me a first number. If I again write next, it will give me the next number. If I write print again next of g, this will give me the addition of previous two numbers. If I again write print next of g, this will give me 5. Okay, so it's giving me addition of previous two numbers. So what is the concept of generators? So whenever I write a function call, so it will return me just a generator object. It will not execute the function. So whenever I write a next, it will start executing the function from first line till it encounters the yield statement. Okay, so now whenever it encounters the yield statement, this is the output and it will return the output here, and it will maintain the state of this particular function. So once I printed the value, it will go back, and whenever there is again a next call, it will start from this statement and it will complete the execution till it encounters the next yield statement. Okay, now I can write multiple yield statements in a generator function. Now Fibonacci series generally starts from 1. Okay, so here I have defined first num and the second num. What I will do, let me write another yield statement here. Yield, let's say second num. Now check the output. So now it will give me this 1, then 1 again, then 2, and then 3. Okay, so for a generator function, execution will be from yield statement to the next yield statement. So let's say if I want now first 10 Fibonacci numbers, then I can say for value in range of 10, and let's say print next of G. If I execute this, it will give me first 10 Fibonacci numbers. If I want more, if I want next 20 numbers, then I can write another for loop. Let's say for value in range of, let's say this should execute 20 times, and then print next of G. As we discussed, generators will maintain the state of function. So for first for loop, it generated 10 values and it maintained the state, and for a next function call, it continued from the next number. It didn't start from 1 again. Okay, so generators will maintain the state, and this is like a lazy evaluation of your function. It will give you one value at a time. One important point about generators. So let's go back to our first function. Here, instead of printing, I am saying yield value. Yield value. Okay. After function call, I will get a generator object, and let's try to print this next of G. This will give me the first number. Let's copy this, paste it again. Second number. I have 6 numbers, so 3, 4, 5 and 6. It has printed till 60. What will happen if I write another next call? Now I don't have any number after this. So if I execute, now this time it will throw a stop iteration exception. Okay, so this exception you have to handle using your try and except block. So this is the same exception your normal for loop handles automatically, but in case of a generator, you have to handle it using try and except block. So we have already discussed list comprehension. Let's discuss what is generator exception. Again, let's take the same problem. I have a list of numbers and I want a square of each number. Using list comprehension, we will write something like this: value into value for value in L. And now if I print L2, this will generate the entire list. If I just change the bracket, instead of square brackets, now I'm putting parentheses. So now I will get a generator expression. How to get a values now? Again, I need to give a call to next function. So now if I say next of L2, I will get the first element. Copy this. So even if you are using comprehension and you are getting a large series of number, then that also you can convert to a generator expression, and using next function, then you can fetch the value. So why we need generators and generator expression? So whenever we are writing functions, and if it is generating a large number of number sequence, then it is a memory consuming operation. If you are using generators in your program, you are reducing memory consumption of the code. because ultimately instead of generating entire series of values at one time, you are generating one at a time and you're processing that. Okay, so it will save a lot of memory, and this is one of the best way to save memories in Python. So that's all about generators. If you have any queries, post it in comment section. We will go through them. Thank you.